Hello guys, this is a juicy little number. We're cracking on with the Barker past paper we've been doing. We're up to 11D now from the Extension 1 Semester 1 past paper in 2012. I haven't written 2012 there. And this is just an absolute beauty. So the question is, you're directly south of this, well, it's a tower, but it's more fascinating for me if it's a mountain, right? Pretend it's a mountain, right? And it's really hard to climb up. You don't know how to climb up it because, say, it's like Everest or something and it's dangerous and it's 1700s and you don't have the technology to get up there. What you can do is just be directly south of the mountain and measure this angle. So say it's 45 degrees. Then walk 100 meters east, just directly east, so this is a right angle, to this point at B. Then measure the angle of inclination to the top of the mountain, 30 degrees. And from that alone, you don't even have to climb up the mountain. You can work out the height of it. So that's what this question is doing. So it says a surveyor stands at point A, which is due south of the tower, OT, and the tower's H meters. The angle of elevation to the top of the tower from A is 45. So this is 45. So this is a right angle here because it's, directly up. We also know this is going to be 45 because 45 plus 90 in this little triangle here is going to be 180. Beautiful. So the surveyor then walks 100 meters due east. So he fangs a righty and goes 100 meters due east. Then measures the angle of elevation to the top of the tower or the mountain. So that's 30 degrees up. And then we're going to do these questions. But just think about how clever this is. That there are ways of measuring the heights of things, like you can get barometers, and now we've got satellite images and all kinds of things. But I reckon this is probably, I haven't done any research, but this is probably how people in antiquity did it, like really old school clever guys like Greeks and that. Really interesting stuff. Anyway, so what we're going to do is, it says express the length OB, so that's from O to B, just in this triangle here, in terms of H. So I've just drawn this diagram out again. So this is the OBT, which is just this triangle here, OBT. And we've got to write this length OB in terms of H. So it's a right angle triangle, so we can do trigonometry. So we can do our little soccer tower. So what I'm going to do, so this is the adjacent side, this one here. This is the opposite side. So tan of 30 is opposite over adjacent, so it's H over OB. Now, what's tan of 30? Tan of 30 is, I've just drawn up our little, you might just remember tan of 30 directly off the bat as 1 over root 3, but I'd like to draw up my little triangles here. So it's opposite over adjacent. So tan of 30 is 1 on root 3 equals, beautiful, H over OB. Now we'll just do a quick little cross multiply. We'll have OB equals, that looks like some kind of weird sign, OB. That does not look any better, but you get the point. OB equals H root 3. So it said express the length OB in terms of H. We've done that. OB in terms of H. 1 mark, couldn't be easier. Now, question 2. Show that the height is 50 root 2. So this is the part where, like, it's only worth 2 marks. It's so easy to find the heights of mountains without going up them, which I just find really cool. So what I've done down here, this diagram here is the floor. So we've got OAD. So this is north and this is east, and it's 100 meters from A to B. It's this distance here. And we've just worked out that this distance OB from there to there, or this is H root 3. Fantastic. So what the general plan is for this, we're going to work out the distance OA in terms of H, like what we've done in the first part, except in this triangle here, and get an expression for OA in terms of H, and then pop it in here, and then we'll be able to use Pythagoras' theorem to work out an expression just for H on its lonesome. Very clever. So I'll show you what I mean now, and if some of that went over your head, don't worry, because I'm just about to explain it in more detail. So this triangle that I've just drawn here, AOT, is this triangle here, AOT, the one in the vertical direction. So you can see that we've got a 45 degree here and a right angle. And this H here is the height of the tower. I've said mountain a few times, but, same thing. So we've got opposite and adjacent. Remember, we're trying to find an expression for OA. So tan of 45 equals H over OA. Beautiful. Now, tan of 45 is 1. So 1 equals H over OA. And then, of course, we just times both sides by OA. H equals OA. And the reason that is because this is 45, and like I said earlier, this would have to be 45 as well. 45 degrees. Oh, that's not a 45 degrees, just to make up the angle sum of a triangle to be 180, which means this is an isosceles triangle because the base angles are equal. So that this is, if that's 45 and that's 45, so this also has to be h because it's an isosceles triangle. Anyway, the h, so this OA is h. So this distance here, OA, is just h on itself. Wonderful. Now, so remember, this is the floor diagram of calling it the floor, this level on the flat ground here. Now what we're going to do is a bit of Year 8 Pythagoras' theorem. Beautiful stuff. So we're trying to find an expression for this h. So 100 squared plus h squared equals this squared. So h root 3 squared is 3h squared because we square the h, that's the h squared, we square the root 3, you just get 3 back. One's a bar. So now we're going to minus h squared to both sides, so we get 100 squared equals 2h squared. Cool beans. I'm just going to divide by 2. So we're going to get h squared equals 100 squared on 2. Now, because we're just going to get h on its own, so we're going to square root both sides. Cool banana. So h equals 100 on root 2. Beautiful. So that's an expression for h. Now, first of all, we haven't rationalized this denominator. So if you want to be able to sleep at night and hold your hand up high and die a comfortable death, realizing that you've lived in an honorable way, we're not going to keep this root 2 on the bottom. We're going to rationalize the denominator, and you can see that's what because that's what we need to do, because this is not this has already been rationalized, this h. So we're trying to get it into this form. So, remember from year 9, maybe, we times by root 2 over root 2, because this is just 1, so that's cool. And then we get 100 root 2 over 2. Beautiful. Now look at this. Look what's popped out. H equals 50 root 2. So we've just divided the 100 by 2. And that's all we needed to do. H is 50 root 2. And that's what we had to prove. So that's awesome. We haven't climbed up this mountain. We've just been running around on the ground level. Like, it's not that hard. Sit here, measure 45 degrees, walk 100 meters to the right, measure 30 degrees angle inclination, and then give it to your maths teacher or yourself now, because you know how to do it, and he can tell you how high it is. I just think that's really cool. Anyway, so the third question is calculate the bearing of B. So calculate the bearing from the base of the tower. So when we're here, what is this angle here on the flat? So we're trying to find this angle just here, the bearing of B from O. So what we're going to do is, here's the general game plan. We're going to find an expression for alpha, this angle in here, just using a bit of trigonometry. And then what we're going to do is, and then this is just going to be 180 minus whatever that is, and then we'll have our bearing. Wonderful. So this is quite a long video because it's got 3 parts to it. So I'll just do this. So we've got a few options. Let's do adjacent. So let's just do sine. So sine of alpha equals 100 over h root 3. And h root 3, sorry, is 50 root 2. So I'll just times by 50 root 2. Beautiful. Sine of alpha, I'll just clarify that again, equals, so we're going to have 100 divided by 50, that's going to be 2 on root 6. Beautiful. Cool. So now what we do is we find the inverse. So we go alpha equals the inverse sine, because we're trying to find this angle alpha, over 2 root 6. Beautiful. So remember, alpha is this little angle in here. And we just punch that into a calculator, which I've just done now, and we get alpha is, let me go my calculator, 54.74 degrees. Wonderful. So that means that this angle in here is 180 minus, and when you pop in 180 minus 54.74, this angle in here is 125 degrees. True. So I've just rounded off to the nearest degree. And true just means you start at north and you're going right 125 degrees, which looks about right because it's a bit past this 90, and you keep going a bit. So beautiful. So that's all these 3 questions done. 5 marks in the bag. Thanks for coming. I hope it was clear. I've just gone over the 10 minutes. So see you in the next video.